This is a new frame about domain and range. And again, just to remind you, the frame is like a reference document that we create in class, usually doing some kind of exercise together. And we create this so that we can have a document to look at when we're studying or trying to solve a domain and range problem during while we're practicing at home or even in class while we're practicing. So our topic here is domain and range, and we start with just the definition. The domain of a function is the set of all possible input values, and the range of a function is all of the possible output values. So it can be a little tricky to find those sometimes. It's helpful often to look at a graph of a function in order to understand that. But we are studying rational functions right now, so we'll be thinking about the domain and range of rational functions, at least for these first two. And then, there's a quadratic down here that we'll also try to think about the domain and range of that thing as an exercise. So let me just go across the first row of this thing first. So we're going to consider the domain and range of these three functions. And we're going to write the domain and range in 4 different ways. We're going to write it in words. We're going to write them using what's called inequality notation. And we're going to use a different notation called interval notation. And then finally, we'll use set builder notation, which is really this most compact and really mathy way of writing the domain and range. So let's start here. It's easiest to just think about all of the possible input values to this function. That is, all the possible values of x that we can put in. And you should know from our study of rational functions that as long as an x value doesn't cause a function to be undefined, then it's a perfectly reasonable value. So the value that causes this function to be undefined is 0, the value of x. So I can put any other number into this function for x except for 0, because 0 would cause the function to be undefined. So the domain, and I'll just represent that with a D, is all real x. Okay, that's all real values of x, except for x is not equal to 0. And that's it. Also, from the graph of this function, you can look at the graph, and we did produce that graph on our other frame, this one, and you can notice that there is a value of y for every single x value except for x equal to 0. There's no y value. And if we want to think about all the possible y values, notice in this case we have values of y for every single x value except for we don't have y equal to 0. You're never going to get 0 out of this function. And you can think about that in a couple of different ways. Imagine I tried to solve the equation 1 over x equals 0. There's no value of x that I can plug into this function that's going to give me 0. I can plug in a really, really large number and I'll get close to 0, but I'll never actually get 0 out of this function. And so the range of this function is all real y values, okay, except for y is not equal to 0. And that is the domain and range of this function. So now we're just going to translate that information into several different notations. It's the same information, we're just writing it in a few different ways. So inequality notation. And inequalities are like less than, greater than, less than or equal to, greater than or equal to. And if I want to represent all of the values of x except for x equal to 0, I can say that x is less than 0 and x is greater than 0, but x is never equal to 0. And it turns out that my range for this function it's the same values actually. Y is greater than 0. It can be any number greater than 0. And it could also be any number less than 0. For some reason, I turned those around, but it's still the same information. Y is any number greater than 0 and any number less than 0. That is the range of this function, all the possible output values. Interval notation, you may be familiar with that from previous math classes, but the way that we represent interval notation, it's a little more compact, is we use parentheses and brackets for the ends, and I use the parentheses to indicate that, well, let me just finish writing this. I can say that the domain goes from negative infinity, let me fix that, from negative infinity all the way to 0, but not including 0. If I wanted to include the 0, I would use a bracket, but this indicates just less than 0, and then all the way down to negative infinity. And I'm going to use the union symbol here because I'm including every value from 0 to positive infinity, but I'm not including the 0. If I were, I would have a bracket right here. The range of this function is the same. The range, it goes from negative infinity all the way up to 0, but not including the 0. And then I'm going to take the union of that set of numbers and go start at 0 and go all the way to positive infinity. And that's how we do interval notation. If it's a little bit confusing or you haven't seen that before, then I will post some resources for you to kind of brush up on that and think about the meaning of that notation. The most important thing really, though, is to be able to describe using words what it is that you can put into this function and what it is that you can possibly get out of this function. And then set builder notation also might be a little bit cryptic if you haven't seen it before, but I will represent it here. The domain and the range. The domain, again, is, and I'm going to use this brace, okay? The domain is all x in the real numbers. That's all real x, so x is a member of the real numbers. Any x that's a member of the real numbers, such that x is not equal to 0. So again, this is the most compact and maybe cryptic way of writing the domain, but definitely the most mathy. And one of the reasons in math we like to write things in a very compact way. So you may see this notation in your higher level math classes moving forward, and we definitely want to introduce it here. But I'll say this again. What's most important about domain and range right now is that you can actually describe in words what the possible input values are and possible output values are of a function. The range, it's kind of an easy problem because the range is the same values as the domain. It's all y in the real numbers such that y is not equal to 0. And that is how 4 different ways to write the domain and range of a function, specifically this function right here.